so that the understanding can be consolidated, the concepts can be cleared. So here you have the same customer A site 1, which is Indian Railways, customer B site 1, which is DRDO, and the IPv4 address, which is 172.16.10/0, and they are also the same, it has to be transported. So the basic concept or the basic idea why I wanted to show the slide is that how it actually happens, how these things are being created in that virtual router. So in this physical router, which is the provider edge P1 router, in the autonomous system number 1 implies that this is of the same service provider. So MPLS VPN service provider AS1. AS1 is the autonomous system number, which we will discuss tomorrow again. So it's a number. It can be a number like 9600. So that 9600 is a unique number. This is an AS number, which is unique to the service provider. Just like public IP is unique, the AS number is also unique. So in that provider edge 1 AS1, we have the VRF for customer A, which implies there is a virtual router for that customer A. It has got an RD value of 1:100, an export value and an import value of 1:100. It has been kept same. It can again be same, it can be different also. Just for understanding, it has been kept same. An RT export of 1:100, it is generated, and RT import of 1:100 is generated. And the VRF for the customer B will be there with the RD values and the export and the import values. So like we know, the RD value, the route distinguisher, is to make that 32-bit address unique by converting it to 96-bit address. The RT export will identify the membership to this VRF. So this is how it is being labeled. So from number 1, that is the customer is sending the information with this IP address. It goes on to the router, it creates the number 2. Number 2 is the creation of the VRF. So same thing with the customer B, the packet is being transferred and the VRF is being created. After this RD, RT, VRF has been created, it goes on to create the VPN v4 address like we have discussed. Now because it's a VPN v4 address, it's a 96-bit address, you require the multi-protocol BGP. The normal BGP will not work, you require the multi-protocol BGP. So the multi-protocol BGP will transport this VPN v4 address. So this is how it will look, that is 1:100, 172.16, 10.0/32. So now this is a 96-bit address. The reason for putting this slide is to tell you the process by the numbers involved. So this is how it actually works in an MPLS scenario. And similarly, that means it has all the information, like the VPN label is V1 and the next hop. It gets the information of the next hop also. And the next hop will be 10.10.10.101 in the provider edge 1 AS1 router. Similarly, it happens with the customer B also. The VPN v4 address, which is marked here, the 96-bit address, along with the route target, which is identifying the membership, is created. The next hop is identified, and the VPN label is also there. VPN label, the VRF label, you can consider it of that matter. It goes on to the provider edge router at the end. So like this question was asked earlier also, the provider routers, they are happy, they are free, they are only doing the swapping. This thing is happening only between the provider edge routers. So that is a multi-protocol BGP. This is the iBGP updates. That is internal BGP. It is not external BGP. Why it is not external BGP? Because it is within the same service provider. It is internal to that service provider. The updates are internal. That's why they are MP-iBGP updates. So it reaches the other end, and at the other end, you have the same VRF is available, the RD is available, the import RT is there. So that export RT is being imported here. Whatever this router, this provider edge 1 router has exported is being imported by the provider edge router number 2. So that import happens, and the functionalities which we have already discussed, the popping will happen and the IP lookup will happen, and it will be transported to the customer at the other end. And the below representation is nothing that to again consolidate the understanding that the customer one can use any protocol internal to his network. It can be a static protocol, it can be a RIP protocol, it can be OSPF or eIGRP. That protocol is being transported on MPLS and they are being redistributed. These customer routes are being redistributed into MP-iBGP by creating a VPN v4 address. The VRF table is created and it goes from the VRF table, that is from the step number 3 or the step number 2. Step number 2, it goes to step number 3 onto the MP-iBGP. MP-iBGP VPN v4 routes are being transported to the provider edge number 2 and the de-encapsulation or the reverse of that will happen. From the MP-iBGP updates, it will go and identify the VRF and it will import the targets and then convert it or redistribute it back to the protocols, the underlying protocol of the customer. Could be RIP, OSPF, eIGRP or any other route. So this slide is important after the previous slide because the previous slide was telling you the detailed workings and it tells you a practical scenario wherein these things happen step by step, wherein the IP packet that comes from the customer in any of the formats, static, eIGRP, OSPF, RIP is redistributed into MP-iBGP updates. How it is redistributed is by creating VRF, by creating the RD and the RTs. And then the MP-iBGP VPN v4 routes travel from the provider edge 1 to provider edge 2 and the reverse happens with the help of the VRF, RD and RT.
Sorry for interruption, sir.
Yeah, please pardon me.
Sir, can you re-explain this overview?
Sorry?
Re-explain this overview.
No, your voice is breaking actually.
Sir, can you re-explain this overview again?
Okay, I'll do that. I'll just re-explain the overview. So what I was saying is that now we understand everything in the MPLS, understand everything in the basics of the MPLS. We know that the tables have been created. We know the push operation happens, pop operation happens, swapping happens, PHP happens. And we also know that we have to isolate the customers using the VRF, RD, RT concepts. So this picture, this overview is just to consolidate that learning and we can concentrate on this, I would say. We can concentrate on this thing because that is a gist of the above picture only. It says that anything that is coming from the customer, static, RIP version 2, OSPF or eIGRP will be redistributed. The customer routes will be redistributed into the MP-iBGP updates. How they will be redistributed into MP-iBGP updates, that is multi-protocol internal border gateway protocol updates with the help of the formation of VRF, the route distinguisher and the route target. Route distinguisher will make that 32-bit common IP address into a unique 96-bit address. The route target will identify the membership of that 96-bit address to that particular VRF. And because it becomes a 96-bit address and it is no longer a normal 32-bit IPv4 address, we require the MP-BGP protocol. So that will now be transported between this provider edge to the next provider edge using the MP-BGP protocol. So what will that have? This will have this thing. It will have the route distinguisher, it will have the IP version, 4 address, and it will have the route target. These are the 3 things that will have the route distinguisher 1:100, the IPv4 address and the route target, which is again 1:100 just for easy understanding. And it will also have the information of the next hop. That is where it has to go. And then the VPN label, that is the VRF information. It comes to the provider edge router number 2 and there the thing gets unfolded, I would say, if that is the correct word to use. From MP-iBGP updates, it gets unfolded into the VRF, route distinguisher, route target information that de-encapsulation happens for easy understanding, and then it is redistributed back into the RIP version 2 OSPF or EIGRP routes. So VPN v4 routes are redistributed into the routes of the customer. Whatever came from the customer is given back to the customer by all this underlying technology. So that is how it happens. And this is, again, to reiterate myself, is a service provider technology. The service provider will be doing it. Why the service provider will be doing it? Because service provider has to make its operations scalable. It will only be able to make it scalable if it is able to achieve that isolation, because a service provider will be dealing with thousands of customers. Thousands of customers can have the same IP schema, they can have the same protocols being used, so the service provider has to isolate them and provide the services. Okay, so this is an overview of working as well as an overview on the need for that setup. That is also important to understand.
Ankurji?
Yes.
This concept is called L3 VPN.
Now, L3 VPN, what I would say is this is not L3 VPN. L3 VPN is simply that you will be sharing, or it works on the layer 3. Okay, in a sense you can call it, but yes, it is a basic for everything. It is not just a basic for L3 VPN, it is a basic for everything. It is a basic for GMPLS, it is a basic for MPLS TP also. In a sense, yeah, you can say it L3 VPN because the customer routes are being seen by the service provider. So that is the basic differentiation.
And in this scenario, these customer networks are not maintained in the MPLS routers, the P routers, isn't
Exactly.
it? So for that extent, the MPLS routers are remains light. It's not overloaded.
They are being maintained only in the provider edge routers. In the provider routers, that thing is not happening because it is a BGP free core. But in the
without IBGP, without this IBGP concept, the all customer routes also maintained by P routers. So with this IBGP routing protocol, I am not going to maintain the customer routes in the MPLS routers. For that extent, the routers are remains light. The routing table is very light.
Not exactly, I would say that. The application of using MP-iBGP is not to make the routers light. Rather, the moment you say a BGP protocol is used, it becomes heavy. By default, a BGP protocol is a processor-intensive protocol. The reason for using MP-iBGP is because it is no longer a 32-bit IP address. So the normal routing protocol cannot transport it. We require a special protocol which can work with 96-bit unique address. So that is the reason for using MP-iBGP and not to make the router light.
No, without this IBGP protocol, all customer routes have to be maintained by P routers of MPLS. Because this IBGP.
No, it is not like that. Even without this thing, that if there is no other customer, so if I say that it is a new thing and a service provider has only one customer out here, that one customer without all these added functionality will work. If no isolation is required, then it will work. That same physical router will be the router for this. So there will not be separate VRF. It has to be created because that is how the technology has been built. But if you want to re-engineer the technology and you don't want to use the VRF concept, you don't have multiple customers, then it will work.
But it will work. It will work, but the network is maintained by all P routers also in that scenario. That network, the customer network is going to be maintained in all P routers of MPLS. But in this scenario, the customer routes are no longer maintained in the P routers.
No, it is not like that. They are being maintained. So if you see here that IP address is being maintained, that is being redistributed from a...
Redistributed?
Yeah, from an OSPF route that has been redistributed into this. So in the redistributed format, it is anyhow maintaining it, right? It is being maintained in the redistributed format.
No, in this scenario also, are P routers maintain customer routes in the routing table of P routers?
As an iBGP updates, as a different update.
It is available. The customer
It is
routes are
available as
available.
iBGP updates, not as exactly what is being seen by the customer. Not in
No,
that.
entry is there. Entry is there or not?
Entry
Please
is
say.
there. See, this is the entry, right? See, 1:100, 172.16.10.0. In this, 172.16.10.0 is indeed the customer route, right?
In P routers, the entry is available.
Entry is available, yes.
P routers.
Yes, this is what the entry is. This slide,
Okay.
that entry is very much available, and that 172 series route is not the route that has been created by the service provider. It is the route that is coming from the customer, but it has been reformatted, redistributed to be visible as 1:100:172. It is no longer just 172.
Okay, right. But I think that entry is not available in the P router. Just check up, sir. In
It is
iBGP,
available, sir. The entry,
the routes are going to be injected through iBGP directly from P router to P router without making available in the P routers. P routers, sorry. That is the concept.
what you are trying to maybe say is that, maybe I got that understanding slightly.
The customer routes are direct from P router to P router, injecting through iBGP. It's transported. They are not available in the P routers of MPLS network. The customer entries, the customer
that customer route has just been redistributed to be displayed as this, to be displayed at 96-bit. Now you can say that 32-bit original route of the customer is not available. That thing is right. But
that is actually the routing table filled up with the network ID, network information. That is not available in the P routers.
That is not available. What is available is even more complex. That 32-bit has been changed to 96-bit and added with an RT information, added with a VRF information. So if you want to just expand onto that information and see what is there, you will get to know that the customer route is there. But the customer route as such is not there, and it is being opened also. It is not being opened because that RD, RT are doing the work, and you need not to do the IP lookup in depth. So in that fashion, yeah, you can say that customer routes are not available, but in reality, they are available, but in hidden format, I would say. They are hidden, they are a black box kind of thing for it.
Oh, okay, sir. Okay.
Fine, then we shall move on to the next slide, I would say. It's just to say what we have started, the advantages of switching. So there are some advantages of switching over routing. And what are those advantages? Those advantages are in terms of performance. A switching has a faster transit time. It is a less delay functionality, and it gives a flexible routing and packet prioritization. So normal thing, what is there in this is this, for example, this is an IP MPLS packet that has come. The IP packet is inserted with the MPLS shim header. So the data link layer and the IP layer, which we have discussed earlier, the layer 3 and layer 2 information is being inserted with an MPLS information. So that MPLS works at the layer 2.5. It is between the IP, the layer 3 technology and the layer 2 technology, and it is able to combine the advantages of routing and switching. How it is able to combine the advantages of routing and switching? Because it is doing routing at the edge and switching in the core. So that's what, just to take you back from where we started and discuss the advantages, or just to correlate it back to the functionality of an MPLS. And what happens with this is it is able to scale it up, it is able to make it simple. So there's an ease of management as such, which is available with this kind of architecture. Now the MPLS performance, the MPLS faster transit over IP routing, it is able to give a faster transit time than compared to a normal IP routing. Discussed how it has done so. As a result, it requires less CPU and less memory. The index lookup of forwarding table as opposed to the address lookup. So it is all based on that label that takes place. The labels are generated and it is no longer this IP address has to be looked up. The forwarding tables are small, contains the label switch routers as opposed to all known IP networks. That is, an OSPF protocol will information of the entire area, but in this case it will have the information of only. The internet routing table contains more than 70,000 table entries. So that is what, just to give you a sense that how many entries could be there in the routing table. It all depends upon the router backplane capacity also, but that's an average, or wherein there could be 70,000 table entries. So the routed packet is actually going through the layer 3 format, that is, it is going through the IP thing, but a switched packet is actually moving from the MPLS. That is how the performance gets enhanced, because it is no longer a routed packet that always has to go for the best fit IP address lookup, but it is a switched packet in the core which can work on the forwarding table, which is smaller. See, the size of the forwarding table is smaller in case of an MPLS technology, and as a result it is faster, it requires less CPU, less memory, less transit time. So that was all on the MPLS performance. With this we can discuss questions. I will go on to this mode and we can have some questions.
Sir, what is AS?
What is
AS?
AS is the autonomous system number. We will be discussing in the BGP classes. Autonomous system number is a unique number which is assigned to a service provider. The way public IPs are assigned, which become unique on the internet, AS number is unique to the service provider. Airtel will have its own AS number, BSNL will have its own AS number, Railtel will have its own AS number. Why it is required? It is required in order to identify the service provider over the internet. So that is the BGP protocol. When we talk about the external BGP protocols, the eBGP protocols, that time the AS number always gets in the BGP. BGP route will always have. Just I can show you one thing. 1 minute. So, example. So, for example, one cloud, this is another cloud, this is third cloud, this is fourth cloud. Fourth cloud in the sense, this is Railtel, this is BSNL, this is Airtel, this is Vodafone. A packet. Okay, some user is trying to access some server which is actually there at Vodafone. Now this is again very simple thing to tell you, but again there are complexities in the sense that there will be it is not like that. It's just a simple, I would say, other form to just tell you the AS number, but in actual it is not like this. Okay, there is a NIXI also involved in picture which does certain things. So if someone has to access this server and it is being at Vodafone and he is a user of Railtel, then that packet will actually transfer to all these people, and all these people will have their AS number. There will be an AS number, for example, number 1, number 2, number 3, number 4. So that will be appended onto that BGP update. So whenever BSNL receives that update, it will have that AS number in that BGP update. Whenever he receives it, it will have that update. That is, there will be an IP number. There will be 1 and 2 also added onto that information. So Airtel will receive something like IP12, that is AS1, AS2. Vodafone will receive IP, whatever that IP address is, 1, 2, 3. What I wanted to say is that AS number is important to uniquely identify a service provider over the internet. So that is a concept of AS. Yes.
Ankurji. So what is the agreement between the AS network, sir? Every AS is connected to every other AS in the whole network. internet working.
No,
if I want to...
that actually depends upon the service provider, how many peerings you want to have. Agreement is with the NICSI. As per the rule, every service provider has to have a peering with the NICSI.
What is NICSI, sir?
NICSI is the National Information Exchange Center of India. Something of that sort is the definition. NICSI has been created by Indian government. It is to have the peering of the service provider, just as a mediator we can say. But the service providers can have direct peerings also. For example, RailTel have direct peering with Airtel, with Vodafone, even with other providers also. So that with Google, Microsoft, RailTel has peerings as such.
Sir, for example, in your diagram,
sorry, please pardon me.
No, in your diagram to reach this Google AS, suppose I have to go through the Yahoo, but I connected to some VSNL AS. All the way my traffic is going through the Yahoo, where I connected VSNL and going to Google, but my traffic is passing through Yahoo. How they are allowing? Because they are again bandwidth is problem, no?
No, it is not Yahoo. Yahoo is a different server. Google is a different server. You could be a user of BSNL, but if that particular server is not hosted in the BSNL network, then you will in the sense your packet will have to traverse to all the service providers and ultimately reach to the service provider who is actually hosting that server. So Yahoo and Google, that is a different thing. In order to reach that server, if that is locally hosted by that service provider, you will not have to move to another AS. But if it is hosted in other service provider, you will have to go through eBGP path and then use all the AS numbers and find where it is located.
But it is not like that every AS is connected to every other AS in the internet working. Not like that, no?
Not like that. That's why I told this is a very basic thing to tell you about the AS number. That's what in the beginning itself I told, just to tell you what AS is. It is not the actual scenario. The actual scenario is different.
What about in RailTel scenario, sir? How many AS is it's connected? Your RailTel MPLS?
RailTel is connected to Google, Microsoft, Airtel, Vodafone, Reliance. Yeah, these are the major service providers RailTel is connected. And obviously NICSI, BSNL also it is connected.
Within the India?
Please.
Not overseas. They are available within the nodes are available within our country, no?
Yes, that means
Facebook is there.
NNI that will be established.
NNI, okay.
There will be a network interface with all these service providers within India. These service providers in turn will be connected to service providers outside India. So as a result, RailTel is connected to everyone.
Okay. Okay, thank you.
Shankur, I have one more doubt.
Yes.
This as a service provider, when you plan to normally implement MPLS, that means if the distance is the, for example, if one subscriber is there, he is having 2 branches within Hyderabad, then does it require him to give an MPLS connection or not required?
See, if the customer is only in Hyderabad, then MPLS is not required. The customer has one location in Hyderabad, one location in Chennai, one location in Mumbai, and all these locations talk to each other on a secure private network, then yes, they are given an MPLS connectivity. So, for example, I'll take a real of DRDO again. DRDO has got some 50 plus labs across India. So all those 50 labs want to talk to each other. So they are given an MPLS network. In addition, these 50 labs also want to access the internet. So the internet is given at the central location. So if I just draw a small pictorial representation, what happens in this is, for example, this is the Delhi DRDO. This Delhi DRDO is Intel Cloud, there is a Bangalore DRDO, there is a Hyderabad DRDO, there is a Chennai DRDO, there is a Kerala DRDO. All of them are given 20 Mbps of MPLS VPN, all these labs. They are on MPLS. And this Delhi is given a 1G of MPLS and he is given a 1G of IBW. IBW is the internet bandwidth. Now this Delhi, because he is the headquarter, he is having a firewall here. And after the firewall, he has the internet. That means the internet is being connected. So a person who is in Bangalore, if he wants to use the internet connectivity, he will actually go through the 20 Mbps VPN pipe, find an LSP, goes to Delhi, goes to firewall, access the internet. If he wants to talk to Chennai, again, he will go to this pipe, he will go to Delhi. From Delhi, he will be rerouted back to Chennai. So Delhi will act as a central coordinator for either the internet access for Bangalore or for talking to Chennai. That is how it is. But if it is only one single location, then there is no point of giving him the MPLS. He would rather be given an internet bandwidth. If that makes sense.
Ankur ji, my last question.
Yes.
What is the longest link available in your MPLS, Railtel MPLS, and how many routers are there in that link, and how far this label switching is benefited?
Oh, that's a different kind of question to answer. Like what I could say is, like I have answered it yesterday also. Between routers, it is longest link is immaterial. Reason being, router to router links are not there in Railtel. They are either on the backend through SDH or through DWDM. So if it is an SDH, the longest link in that case is the STM64 long haul connectivity, which is approximately 80 to 90 kilometers. But if it is a DWDM connectivity, which is
not distance, sir, not distance. How many hops, how many routers are there in one link? Routers, the hops.
See again that
maximum links.